In this session, we will be looking at using the logical operations in R. So, whenever we are talking about a logical operation, something that will evaluate to true or false, right? So, here we would be seeing the reserved words called capital TRUE and capital FALSE representing true and false. Now that R is case sensitive, the changing the case would mean something else. Now, if I quickly want to check whether true is equal to false, right? So the comparison is done with a double equal to, and because these two are not equal, it is giving me false. Similarly, if I say I want to check whether true is not equal to false, then it is giving me true. Yes, these two are not equal. So I can very well do the testing using these two operators, true and false. Now, let's say I want to check the equality associated with real numbers, right? So initially, if I say 2 is equal to 2, is 2 equal to 2, I'm getting an answer of true. But is zero point 0.2 is equal to zero point 0.2, still I'm getting true. But let's do one thing, 0.3 minus 0.1 is equal to 0.2. It is giving me a false. This is where the floating point arithmetic will have a problem, especially when I am doing the subtractions, right? This is where we have a problem with respect to the floating point arithmetic. The reason, just check out what is the value of 0.3 minus 0.1. It's giving me 0.2. But when I'm doing an equal to, whether it is equal to 0.2 or not, it is saying it's false because there will be some level of rounding of issues associated with respect to the floating point arithmetic. So the best way, I'll tell you, if at all we are dealing with comparing the floating point numbers, especially decimals, I don't suggest using the equal to sign. Now, another example I want to give. Let's say I want to assign a value of x as the square root of 2. Right? I want to find the square root of 2 and I want to assign it to a value x. So this is how we do the assignment. You know it. It's a less than symbol with a hyphen. Now if I am saying x, I am getting some such value. Now again, I am assigning x squared. Probably x squared. I am computing the x squared and assigning to x. Now the value of x, I am getting it as q. Now I want to really check, is x equal to 2. I am getting it false. The reason being, if I compute x minus 2, I get one small value. Something into 10 to the power of minus 16. It's a very, very small value, but still it is not 0. Right? The reason is, when the system tried computing the square root of x, it rounded it at some point, and again when I am taking the square of it, the square is taken only on that rounded number, and the subtraction of those two is not exactly equal to 0. That is where, especially if I want to ignore these kind of minute stuff and I still want to compare the equality, then we talk about using all dot equal. All dot equal x comma 2. Here it gives me true, saying yes, these two are equal. So let me take x as equal to 2. So especially for floating point numbers, probably you can check now, all dot equal 0.3 minus 0.1 comma 0.2. This gives me that these two are equal. So especially if I have to do a floating point equality comparison, I suggest the usage of all dot equal rather than doing a simple equal to for comparison. But for integer comparisons and all, I still suggest using the equal to. But all dot equal to, if I have to, all dot equal is what is preferred to use when we are doing a floating point comparison. Now, there is one more aspect with respect to the all dot equal. In case they are not equal, right? So let me assign three variables. Let's say I'm talking about assigning to a value a three variable or probably a vector of three elements. So vector we always concatenate using the C function. So I'm talking about, let's say, cat, or probably let's simplify it, x, y, z. I'm giving three string values x, y, z, and I'm associating that to a. Now if I'm defining a, I'm getting it as x, y, z. Now I'll convert them into factors. So I'll assign a variable called b, which will convert the values of a into the factors, right? So what is happening to b now? B has two things, x, y, z. The levels are x, y, z. Now I want to really compare whether a and b are equal, because now a is the characters x, y, z. B is the characters converted into factors, characters assigned the values of the factors. Now I really want to check out with all dot equal whether A and B are equal. Now it says no, they are not. If they are equal, it will give me true. But if they are not equal, the characteristic of this function is it will give me what are the differences. If I see this, the first one is having a mode of character. Yes, they are all strings. Whereas the second one is numeric. The moment we do a factor, the characters are getting converted into numeric. So which means their modes are not equal. That's where they are different. Then if I look at the attributes, for this there are no attributes. The target is nothing but the one that is on the left hand side, which is A, and the current is something that's on the right hand side, that is the B. So the target is having no attributes, whereas the current is having a list. Because why it's list? It has two entities. Any factor is defined by two stars, right? So that's the reason we have it as a list. If I'm looking at B, we have already checked, we are getting the levels of B separately. The target is a character, whereas the current is a factor. And because of that, we see that these two are not coming out to be equal. So even if there are type differences, still it will give us a kind of an error. It doesn't say false. This is where I have to be very careful. All dot equal either gives me an output of true if they are matching. Otherwise, it gives me what is the error rather than saying false. So that's the reason it's always better to use it in the context of is true or is false of that entire stuff. So probably if I say is dot true, all dot equal a comma b, or is dot true all dot equal a comma b. Let me just check what the function is. Sorry, it is true, I suppose. Is true all dot equal a comma b. Now if I put this, I'll get the answer either false or true. So it's always better that you superimpose is true on the top of it, so that you will get it as either true or false depending on whether it is true or false. Now, especially if I have to find another introduction of logical characters like and, or, if I want to know how these are typically used with true and false, what will happen for true and true, what will happen for true and false, if I really want to know in each of these cases. And here one more thing which we are going to introduce is NA. NA represents missing value, right? Not available. So it's a missing value. So what I really want to see is, if I really want to know all the possible combinations, I'll assign X a kind of values, where I am looking at three values to be assigned. One, I'll take NA, true, false. I want to take pairwise combinations of X completely, right? So if I really want to take that, I say outer is the one that does combinations. So I say X comma X. So do it with combinations of X and X, probably with an and. With an and, do the outer. So what it is saying, the first one is NA, NA and NA is NA, NA and true is NA, NA and false is false. So what we see is, wherever false is coming, the outcome is coming out as false. True and true is coming out as true. And when true NA is coming with true, the outcome is operating out to NA. But when NA is coming out with false, the outcome is coming as false itself. Whereas if I am trying out with R, X comma X comma R is this piping operator. If I am trying this out, now we see something different. Wherever true is there, in case of R, wherever true is involved, the outcome is working out as true. Wherever both of them are false, false or false is false. But if the false is there with NA or NA in isolation, we are getting the outcome as NA. So basically, to summarize that, it is like true in case of and, right? False and anything, true or for NA or false, is going to be false. Whereas NA, if it is coming out with either NA or true, then it is coming out, then the outcome comes out as NA. But if true is working out with true, then only the outcome is coming out as true. Whereas in case of R, true with any of them, true or NA or false, all of them are working out to true. And NA, if it is operating it out with NA or false, you are getting NA. And finally false, if it is operating out with false, then the outcome is coming out as false. So these are the various things that can very well be checked with your outer function as well. So the different combinations of and or logical functions can be understood through this combination. Then the other important area where logical functions play an important role is the logical arithmetic itself. Very useful in programming and the selection of the variables. So here one thing we have to understand is true by default is assigned a value of 1 and false by default is assigned a value of 0. So if I really want to check what happens, let's give some simple values to X. Let's say X takes values from 0 to 6. And I really want to know x values which are less than 4. So it's, you see here the outcome comes for the first 4 elements it's showing true, and after that it's showing false. Because the first 4 elements are 0, 1, 2, 3. They are less than 4. So they are getting evaluated to true, and the remaining ones are getting evaluated to false. X greater than 2. So the first 3 things are not greater than 2, whereas after that they are all greater than 2. So that's where it is showing this kind of a number. Then if I want to know if all of them are greater than 0, then I can simply say all x greater than 0. So are all of them greater than 0? No, one is 0. That's the reason it is showing false. Otherwise, if I see all x less than 7, are all of them less than 7, it is giving me true. Similarly, we have another thing called any. At least one of them is it satisfying the rule. Any x greater than 5. It's true. Whereas any x greater than 7 is false because none of them is greater than 7. So all and any are typically used to indicate the total. Is there everything greater than is everything following the rule, or at least one of them following the rule? All and any are used for that purpose. And I can do some kind of arithmetic also. I really want to count how many of them are less than 4. So all I can do is I use sum and say x less than 4. So x less than 4 is typically is this one. And what it will, what I have said, each one is given, true is given 1, false is given 0 by default. So if I am doing the summation, it will do the summation of 1, 1, 1, 1, 0, 0, 0. So it will give me 4. There are 4 values which are less than 4. So we can do a summation, and we can use the logical operator which can give us the total count of values which are following a particular criteria. And even let's say I can do a multiplication also, right? Probably if I say y is some other values, right? Y I say, let's say 3 to 9, right? Y is 3 to 9, and I can say y multiplied by x less than 4, right? Y multiplied by x less than 4. Now you see x less than 4 is 1, 1, 1, 1, 0, 0, 0, and y is 3 to 9. So they are pairwise multiplied, which is giving me 3, 4, 5, 6, 0, 0, 0. So even that kind of multiplications and other calculations also can be very well done using the logical arithmetic. So we should be very much comfortable using the various logical operators and logical functions within R, which can help us in solving a lot of queries once we look at our data. If I want to do some kind of comparisons on the data, this can really help me out. All right. Thanks a lot for listening to this session. Thank you very much.